Concerning masonry, we will look now at two particular mechanisms of decay: moisture in masonry and soluble salts. Structural issues and mechanisms of decay in stone, brick and mortars will be covered later in the unit. Water in masonry is determined by the direct contact with water or water-vapor balance, evaporation, condensation, absorption. It needs measurement of the temperature and humidity both in the masonry and in the air. It depends on climate and time of the year, and a cyclical assessment is required for an accurate diagnosis. Soluble salts in masonry can be present in the stone or brick or coming from the soil or the air. Portland cement is also a potential source of sulfates. Salts attack liquid water. Damaging effects are intimately linked with wetting and drying cycles at the masonry surface. Salts crystallize. As the drying evaporation occurs, salt crystallize, producing the characteristic white crystals known as phosphorescence. The most damaging are the hidden salts, cryptofluorescences, occurring in the pores below the masonry surface. Deterioration rates of masonry strongly depend upon the conditions of its surface. Porous materials are subject to mechanical stress. They are brittle, which means that they are hard, rigid, and fragile. They resist compressive stresses better than tensile stresses. External stress are imposed loads, but also thermal expansion. As construction materials are subject to temperature cycles depending on seasons and day and night. This creates a differential thermal expansion with substantial differences in the thermal expansion coefficient of each material. We can see here approximate and restrained movements on 1 meter long piece of material for a 30 degrees change in temperature. We should highlight that steel and concrete have coefficients almost twice as large as those of brick, stone, and lime mortar. This is very important consideration when designing structural reinforcement of all structures with materials such as steel or concrete. Two elements rigidly connected tend to expand or contract in a different way. This develops stress in both, but it is the weaker one breaking or being deformed, which means microscopic cracking is undergoing. For this reason, all masonry elements near modern reinforcing structures undergo an accelerated deterioration. Large stresses can happen inside a porous material when crystals of ice are formed in the pores, frost, or when water evaporates, leaving behind crystals of dissolved materials, salt crystallization. The following deterioration mechanisms develop: frost, salt crystallization, alveolar erosion, efflorescences, corrosion of iron clamps connecting stones. Concerning chemical processes, corrosion is a chemical reaction which always requires the presence of water. We should make a distinction between water provided by direct action of rain, which is always slightly acidic, and water films deposited in the surface by condensation. All the water that reaches building materials by passing through other materials via rising damp or odor is not active from the chemical point of view because it has already been in contact with solid materials of the same type. This kind of water is still dangerous as a possible source of internal stresses.